Well, welcome to the first lesson in Chapter 8, and this will be a pretty easy lesson for you, I believe. This is the Pythagorean theorem and its converse. So we're going to look at what kinds of problems we can use the Pythagorean theorem to solve. So first of all, let's go ahead and look at the Pythagorean theorem and what it says here. The Pythagorean theorem has to do only with right triangles, if you recall. And if the triangle is a right triangle, then the property that holds true is this, that the square of each of the legs added together is equal to the square of the hypotenuse. Now you need to know what the hypotenuse is. It's always the longest side and it's opposite the right angle. So in this example, C, the side C, is the hypotenuse. We call the other two sides the legs of the triangle. And so a Pythagorean triple is a set of integers that makes this equation true, where a squared plus b squared equals c squared. As long as those are, and I misspoke, it's not integers, they're whole numbers where that would be true. If you get any kind of a decimal, then it's not considered a Pythagorean triple. They have to be whole numbers. The other thing that you'll notice that it says in this paragraph as well is each of these examples here are Pythagorean triples. Multiples of each of those would also give you a Pythagorean triple. For example, 3, 4, 5, if you multiply it by 2, you'll get 6, 8, and 10, which is also a Pythagorean triple. So here's our first example. What is the length of the hypotenuse of this triangle? And we're given the two legs, so we're going to simply plug that into the Pythagorean theorem, where the hypotenuse is the longest one, and that is always c. So 21 squared plus 20 squared is c squared. And if we go ahead and solve that for c, we get c is equal to 29. So it says, do the side lengths of triangle ABC form a Pythagorean triple? And since our answer was an integer, or a whole number, excuse me, then the answer is yes, it forms a Pythagorean triple. All right, here's one for you to try. The legs of a right triangle have lengths 10 and 24. What's the length of the hypotenuse? And do those form a Pythagorean triple? Go ahead and pause the video and work on that one, and I'll give you the solution when you come back. All right, I hope you had a chance to try that one. Here is your solution. 10 squared plus 24 squared is c squared because c is the hypotenuse. Working that out, we get 100 plus 576 is equal to c squared. Adding those together, we get 676, and we ended up with a whole number 26, so yes, it is a Pythagorean triple. Here's another example, finding the length of a leg instead. What's the value of x? And we want this in simplest radical form, so no decimals allowed on this one. So first of all, here's our Pythagorean theorem. Substituting in for one leg and for the hypotenuse, we have this. And then simplifying, we get 64 plus x squared equals 400. And then over on the right-hand side, whoops, I skipped a step, x squared equals 336, when we subtract 64 from both sides. And simplest radical form, we're going to break this down into 16 times 21. The 16 comes out as a 4, so we get 4 square roots of 21. Here's another one for you to try. Rather than pause the video, I'll just work through this one. The size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor with a height of 11 inches. What's the width of the monitor? And round to the nearest tenth of an inch. So here's what it's going to look like. The diagonal is 19 inches, the height is 11, we're looking for the width. So first of all, putting that into the Pythagorean theorem, we get this. And then squaring each of our numbers and subtracting 121, we end up with the width being the square root of 240, which in decimal is 15.5 to the nearest tenth of an inch. So here's our converse of the Pythagorean theorem, and it says if a squared plus b squared equals c squared, then it's a right triangle. So now we can identify whether or not things are right triangles based on the lengths of the three sides of the triangle. So the key to figuring these out is checking to make sure that the biggest number in the triangle is always where c goes. So substituting in our values, 13 squared plus 84 squared equals 85 squared. And then simplifying by multiplying those out, do we get a true statement? If we do, then yes, it is indeed a right triangle. Here's one for you to try. Go ahead and pause the video, and we'll work on solutions when you come back. Alrighty, for part A, we have side lengths 16, 48, and 50. So in your triangle, in your Pythagorean theorem, it would look like this. Multiplying that out and checking to see if they're equal. They are not equal, so therefore it is not a right triangle. Part B says, once you know which length represents the hypotenuse, does it matter which length you substitute for A and which length you substitute for B? It absolutely does not. They're both sides or both legs of the triangle, so it does not matter. All right, here's two more theorems for you. The first one says, if the hypotenuse is greater than the sum of the squares of the other two legs, it's obtuse. Triangle ABC is an obtuse triangle. However, if c squared works out to be less than the sum of the squares of the legs, then it's an acute triangle. So let's go ahead and classify some triangles using those two theorems. So we have a triangle with side lengths 6, 11, and 14, and we want to know, is it acute, obtuse, or right? Well, remember, it's acute if it's less than the other two squares of the legs. Obtuse if c squared is greater than the sum of the squares of the other two legs. It's right if it's equal to the sum of the squares. So let's go ahead and plug in our numbers. So we have c has to be 14, and then a and b can be either of the other two. Let's go ahead and simplify that. 196, and we get 36 and 121. Well, when we add these two on the right, that number is less than c squared, so c squared's bigger. So therefore we know that this has to be an obtuse triangle. Since c squared is greater than that, the triangle is obtuse. Try this one on your own. Is the triangle with side lengths 7, 8, 9 acute, obtuse, or right? We'll look at the solution when you come back. Alrighty, here is your solution. 9 is the largest number, so that has to be the c value. Plugging that into the Pythagorean theorem, is 81 bigger, less than, or equal to 49 plus 64? Well, it turns out to be less than, so therefore we can say that our triangle is acute. Because 81 was less than the sum of the squares, it is an acute triangle. Here's your lesson check. Make sure to have all of these problems ready when you come to class tomorrow, and we'll see you next time.